Hi folks, we're going to take a look at question 14 from page 133. So the question says, if the positive z-axis points up, show that this line given here is parallel to and below the first plane, and then parallel to and above this second plane. Okay, first thing you might be asking is, why are they specifying that the z-axis points up? That's normally what we assume, just so that everybody's on the same page as to what it means to be above or below. It means you need to focus in on the z value to determine that. Okay, so here presumably we'll show that the line and the planes are parallel to each other, so we'll assume that here for this diagram. So draw a little picture. Okay, so x, y, and z. Okay, and the idea here is that I've got some plane, okay, and for some x and y value, okay, the plane will have its z value, and say the line is parallel and above the plane, then for that same x and y value, the z value on the line should be higher than the z value on the plane. And similarly, if the line is parallel and below the plane, that the z value on the line should be less than that on the plane. So this is the approach we're going to take here. Okay. So first thing we'll do in A is show that they are indeed parallel to each other. And here we'll use the fact that if the normal, which is perpendicular to the plane, is also perpendicular to the line, then it means the plane and the line must be parallel. Okay, so let's start by taking the normal vector in the line, okay, and show that it's perpendicular to the direction vector. Sorry, the normal vector from the plane, and we'll show that it's perpendicular to the normal vector of the line. Okay, so here the plane's normal vector is 2, -10, 5, and we'll dot that with the direction vector here, which would be 0, 1, and 2. So here we've got 0, -10, plus 10 equal to 0. Okay, so the line and the plane are indeed parallel. Okay, now let's figure out which point we're going to focus on. So I notice here that if I choose t equals 0, the point that comes about is in fact 0, 0, 0. So this point is on the line. Okay, so as I talked about before, for this given x and y value, which in this case here happens to be 0, 0, I'm going to see how the z value on the plane compares to the z value on the line, which in this case here is also 0. So we'll replace on plane, we'll replace x equals 0 and y equals 0, and let's solve for z. Okay, so we have 2 times 0 minus 10 times 0 plus 5z minus 1 equals 0, so those just disappear, and z, when I solve for it, bring that to the other side, is 1 over 5. So I notice that the z value on the plane is larger than the z value on the line. Okay, that must mean that the plane lies above the line, or the line lies below the plane. Okay, so here we have that the line lies below the plane. Okay, let's now repeat for plane 2. Okay, so its normal vector is 1, 4, -2. So 1, 4, -2. And we'll dot that with the direction vector of the line, which is 0, 1, 2. And when we calculate that, well, we get 0 plus 4 minus 4 equals 0. Okay, so that means the line is parallel to the plane. Now we have to show that it lies above it. So again, we know that when x is 0 and y is 0, the z value on the line is equal to 0. So let's put x equals 0 and y equals 0 on the plane, and let's calculate the z value. Okay, so we've got, where's the equation here? So we'll put x equals 0, y equals 0, and here we're left with minus 2z minus 7 equals 0. That disappears, so when I solve for z, the 7 becomes positive, and I divide by -2, so -7 over 2 which of course is less than 0. So the z value on the line, on the plane, is lower than the z value. Oh, sorry, I guess I forgot to show that here. Okay, so let me repeat. I just took x and y equals 0, replaced it into the equation, and I found that the z value turned out to be a negative number, hence lower than the z value on the line when x and y are 0. Okay, and so our conclusion here is that the line is above the plane. Okay, so that's it for that problem here.